Hello, this is Mr. Stein. In this video, we're going to look at the vocabulary for section 5.6, properties of linear relations. After you're done 5.6, you should be able to determine if a relation is linear or not from either the table of values or even easier from the graph. You should be able to graph two variable equations and relate the slope of a graph to a rate of change. So the two vocabulary words that you need to know are linear and nonlinear. And it's pretty basic. Linear just means in a line. It increases at a constant, it increases or decreases by a constant amount. We say a constant rate. Whereas a nonlinear is not a straight line. When I use the word line here, I mean in the mathematical sense. A line is perfectly straight. So it doesn't have a constant rate of change. And we'll see what that looks like by graphing in here a couple of simple relations. The first relation we're going to graph in function notation would look like this. Our function on x is equal to 2 times x. In two variable notation would look like y equals 2x. In table of values, we can put our x here and our y here. Let's put in some values. For x, 0, y, 2 times 0 is 0. 1, 2, 2, 4, 3, 6. There's a table of values. Now let's sketch out a graph here for this. Here's our domain, x. Here's our range, y. We start at 0, 0. All right, after 1, we go up to 2 like this. 2, we go up to 4 up here. And 3, we go up to 6. Now, if I drew this perfectly, these dots will end up in a perfectly straight line. This is linear. Now, if we look over here, we can see in this graph that every time I increase this side, my domain side, by 1, my range side increases by 2. All right, I have my range increases my rise, my domain increases my run. So this graph here has a slope equal to 2 over 1, because every one that the graph moves over to the right, so every time my domain value increases by 1, my range value increases by 2. This is a linear function. This is our constant rate of change. It's our slope. Now, we're going to change this up just a smidge, and we're going to get a nonlinear function. So here's my function. And I should not call this function f because I already have a function f. So I'm going to call this function g. 2 to the power of x. It's a little bit different. So if I write this in two variable notation, it'll be y is equal to 2 to the power of x. Let's build a table of values, and we'll quickly see that this is not linear. X and y. When x is 0, y is 2 to the power of 0, which is 1. When x is 1, y is 2 to the power of 1, which is 2. When x is 2, y is 2 squared, which is 4. 3, 2 cubed, which is 8. Now if we look on our domain, we go up by 1 each time. So that's a constant changing amount. But our range goes up by 1, then it goes up by 2, then it goes up by 4. This is not a constant changing amount. So there is no constant rate of change. Let's take a look at how this looks on the graph. x and y. 1, 2, 3, 4. That's all I need to go up to. 1, 2, 3, 4, 5, 6, 7, 8. At 0, it's at 1. At 1, it's at 2. At 2, it's at 4. And at 3, it's at, way up here, it's at 8. You can see these lines do not end up on a straight line. They end up on a curved line like this. This is not linear. All right. So you should now be able to tell, especially from the graph, if a relation's linear or not. We did graph both of these in two variable equations, and we did relate the slope of the graph, of our blue graph over here, to its rate of change. I hope that's helpful for you. If you have any questions, please put them in the comments below or contact me directly, and thank you.